Okay, so test 1D, the next test, okay, class 10 chapter 1 science. So in this test, the question number 1 is lead oxide plus carbon dioxide. So lead oxide solid, so let us write here lead oxide in the extreme left. Write like this up and down so that you have space on the right side. Now lead is Pb2 plus, we know that. So the 2 plus here and oxide, O 2 minus, so 2 cancel, so lead oxide is PbO, right? So the question is mentioned as solid, so let's put a small s at the back. These things are not absolutely necessary, but it's good to put, especially when it is mentioned in the question, okay? So lead oxide plus carbon. So a little bit below the plus, you write the carbon as given in the question. And we know the symbol of carbon is C. Also mentioned as solid, okay? So it gives you on reaction, when you burn lead oxide in carbon means that coal. You're burning lead oxide in carbon, then you get on the right side in the question paper lead, free lead, so Lead, lead. We know that lead is Pb. Just repeating here, lead means Pb. This is also called lead atom, lead or lead atom, okay? Then lead ion or lead 2 ion is Pb2 plus. They are not same. So when we say lead, we mean the atom, okay? The atom. And carbon dioxide, so plus carbon dioxide. On the question paper, this is mentioned as solid, lead is solid, okay? Then carbon dioxide formula is CO2, we know that. So that is the gaseous form. So once we write the skeletal equation like this from the word equation, then our next job is to balance it, right? So let us start. As I said, balancing is simply by trial and error, right? The more we practice, the more we get the idea and a better grasp of how to balance. It becomes easier for us. There's no fixed rule to balance, right? So Pb here, the back no number means 1. Here also on the right side, 1. No lead there, Pb only in 2 places, so already balanced so far. Next is oxygen atom, so here 1, here is 2. So to make it on the right hand side is 2 oxygen, 1 lead right hand side, 1 lead left hand side, and 1 O. So 1 oxygen atom on left side, 2 oxygen atom on right side, not balanced. So to make it equal to these 2, we put here right in front a 2, which should be bigger than the subscript size here. At the back is called a small subscript. Front is the main script, big letter, bigger size, simply put. So here 2O now, and so now left side also 2O. Once we do that, right side also 2O. But the problem with that is on the left side Pb has become 2, so we have to make the right hand side also 2. So we put here 2, and then now Pb, lead and oxygen atoms are balanced on both sides. One more atom left here, carbon. So 1 carbon on the left, as we can see at the back, no number. Here also the back, no number, so 1 carbon. Only these 3 types are there. 3 atoms, 3 types of atoms, lead, oxygen and carbon atoms, and they are all balanced on both sides. That means the number of each atom on left side are now equal to the number of atoms on the right side, right? That's called a balanced chemical equation, right? So we can now read this equation as 2 molecules of lead oxide, because there are 2 atoms here, 1 lead atom and 1 oxygen atom, so 2 atoms. Anything more than 1 atom is a molecule, so 2 molecules of lead oxide react with, no number means 1 here. 1 atom of carbon, because at the back of C there is no number, means 1, and 1 is atom. So we repeat, 2 molecules of lead oxide react with 1 atom of carbon to give us 2 atoms because of the bag of Pb also. Just like carbon, no number means only 1, and 1 atom means atom. So 2 atoms of lead and 1 molecule because of the bag. See here, 1 carbon atom, 2 oxygen atoms means in carbon dioxide there are 3 atoms. So anything more than 1 atom is a molecule. I repeat here, anything more than 1 atom is a substance having more than 1 atom is called a molecule, and a substance having only 1 atom is called an atom. Okay, so let us read, remembering that 2 molecules of lead oxide react with 1 atom of carbon to give us 2 atoms of lead and 1 molecule of carbon dioxide. So that is the balanced chemical equation. Next is number 2. Aluminium displaces ferric oxide. Only that much is given. So we write here, extreme left, aluminium. So we write here, aluminium is Al. When we write like this, it is aluminium ion, Al3 plus. Al means aluminium. Aluminium or aluminium atom displaces iron from ferric oxide. So from ferric oxide, focus on the ferric oxide. So here you write ferric, and below it you write oxide. Let's make the formula by remembering the starter, ferric Fe3 plus, ferric ion, oxide ion, O2 minus. 2 and 3 valency cannot cancel, so 2 at the top of O will go to the lower backside of Fe, and 3 at the top of ferric Fe will go to the lower backside of O, and that is called ferric oxide. Open your textbook to page 47 and find out the activity series table, whether aluminium is above iron or not. Al is above Fe, and we see that it's above Fe. That means aluminium is much more reactive than iron. So you can easily displace, means remove this Fe to the right side, and will come out as free iron. So even though the textbook did not say this, what this reaction gives as a product, we can figure it out easily, because every displacement reaction we can easily figure it out or find it out ourselves easily by looking at this carefully. So aluminium is above Fe on the activity series of metals on page 37 in your textbook, means in other words it can easily remove or displace iron from ferric oxide, and free iron will come out. Free means alone, not attached to oxygen anymore, free. Okay, and then this Al combined with O means Al and O, just write symbol of aluminium and oxygen. When an aluminium ion is 3 plus, so the 3 will go down. We have to make this formula not looking at this, okay, by remembering your starter. So O means the only common ion that is there is oxide, so 2 there will go to the lower backside of Al without bracket, because these are both simple ions. And we shifted directly because 2 and 3 here, 3 and 2 here can't cancel. So this is, by looking at this formula also we know 3 plus Al, 3 plus means aluminium ion, and 2 go up means oxide ion, so aluminium oxide. So aluminium displaces iron from ferric oxide and give us free iron and aluminium oxide. This is a displacement reaction. So now it's our job to balance. I think we can start from here Al1 and here 2. So you can just put here 2, then 2 ones are 2 Al on left side, and right side also 2. Balance now. Fe2, but here only 1. We're not allowed to balance from back, so in front 2 Fe, Fe2 balanced on both sides now. Finally O, 3, here also 3. So now the equation will read as 2 atoms of aluminium react with 1 molecule of ferric oxide to give us 2 atoms of iron and 1 molecule of aluminium oxide. This is a balanced equation now. So this test 1, A, B, C, D, E, all are, we write the skeletal equation from the word equation and balance them. They are telling us to form a balanced equation from the word equation. So number 3, let's go. Reaction of iron filings. So iron, you can write iron filings. The word here iron filings simply means, suppose we take an iron nail and cut with iron cutter, then we got we get sort of iron powder, right? When we cut the iron nail, that iron powder is simply called iron filings. Okay, so iron, whether it's big solid or filing powder form, is Fe. Symbol for iron is derived from the Latin word ferrum. Iron is English, but its symbol is derived from the Latin word ferrum, the first two letters Fe. So here is a Latin word. Okay, so here iron filings, reaction of iron filings with dilute hydrochloric acid. So plus, you write here dilute hydrochloric acid, chemically is hydrogen chloride only, so H plus, and chloride is Cl minus, so 1,1. So this is nothing but dilute hydrochloric acid. So when you react iron filings, take in a test tube and pour the dilute hydrochloric acid, what happens is that, now open your textbook to page 47 again and see the activity series of metals again and see whether Fe is above hydrogen or not. Fe is above H. Yes, that means iron is more reactive than hydrogen, so you can easily displace this one, and this H will come out as hydrogen gas, H2. You will see the gas bubbles coming out. So if in this test tube you take some iron filings, Fe, and pour inside dilute HCl liquid, then you will see the appearance of some gas bubbles coming out. And if you light a matchstick near the mouth of the test tube, these invisible bubbles of gas coming out burns with a blue flame, okay, and a popping sound like popcorn, like that, a popping sound. It burns with a blue colored flame and a popping sound. Okay, there are many videos by which you can actually hear the sound also, so YouTube, right? So that any gas that burns with blue flame and a popping sound is nothing but hydrogen. Only hydrogen can burn like that, confirming that when you put iron filings and dilute hydrochloric acid, the gas that is coming out is hydrogen. That's because iron is more reactive than hydrogen. Therefore, it will replace this hydrogen atom from dilute hydrochloric acid, and it will come out as hydrogen gas, and the iron Fe will take the place of H, so FeCl. So you just write here FeCl first, and we know the more common ion of iron is iron 2, right? Not ferric but ferrous. So Fe2 plus, and chloride ion is Cl1 minus. This formula we cannot make by looking here, but by remembering our starter. So 1 valency and 2 means 2 will go at the back of Cl without bracket, because Cl is a simple ion, and 1 at the top of Cl will go to the lower backside of Fe, which we not write. And we know that Fe2 here means ferrous, or you can also say iron, because ferrous ion is called iron ion also, or it is also called iron 2 ion, or it is also called ferrous ion. These are the three names of Fe2 plus. So you can write this one as ferrous chloride. That's correct. If you were to write iron 2 chloride also, that's correct. If you were to write iron chloride also. So iron chloride, iron 2 chloride, ferrous chloride is the same compound FeCl2. Okay. Which name you write is up to you, up to your choice, I mean. So now the equation needs to be balanced. This is a skeletal equation, means the equation written in the symbol form correctly with the correct symbol and formula. But it may not yet be balanced. In most cases, it won't be balanced, in fact. So Fe1, here 1, balanced so far. H1, H2, so you put here 2, then balanced. Now 2Cl, and here also Cl2, so balanced. Check once more. Fe1, 2H, H2, so balanced. 2Cl, Cl2, it's balanced. So one atom of iron reacts with two this dilute you need not mention here if you don't want. 2 molecules of dilute hydrochloric acid to give us 1 molecule of hydrogen gas or hydrogen and 1 molecule of ferrous chloride, right? This is 3, and let's go to 4. So 4 is hydrogen combines with nitrogen to form ammonia. So hydrogen, we write like that, extreme left. Now hydrogen is H2 formula. This is hydrogen atom. This is called hydrogen. Hydrogen means the hydrogen gas H2. H is the atom. So hydrogen combines with nitrogen, and we know this is nitrogen atom, and nitrogen is the N2. Nitrogen means nitrogen gas. So hydrogen reacts with nitrogen. Okay, usually it's not mentioned in the question, but high pressure has to be applied, okay, to give you ammonia. So write there ammonia. And from your recalling from your worksheet 1++, we know the formula of ammonia is it's a compound of NH3, a compound containing 1 nitrogen atom and 3 hydrogen atoms. So we need to balance H2 here 3. Now the only way to balance here 3 hydrogen on the right side and 2 is to put 2 in front of the 3 to make it 6. 2 3s are 6, and 3 in front of the 2 to make it 6. So 3 2s are 6, H on the left, 2 3s are 6, H on the right, balance now. That's how we will balance 2 and 3. As I've been saying, strictly speaking, the subscripts means numbers at the back should be smaller. Main script means the numbers in the front should be bigger, like this. So hydrogen balance. Now go to N2. Here is also 2N balance. So we can read now 3 molecules of hydrogen, was more than 1 atom, reacts with 1 molecule of nitrogen to give us 2 molecules of ammonia. Okay, balanced. Now let's go to 5. 5 is hydrogen sulfide gas burns in air. So hydrogen sulfide gas means H hydrogen ion H plus, sulfide ion S2 minus, so 2 will go here. So gas they mentioned, so let's put small g. If they didn't mention, these things are not so strict to put, or you forgot to put also, not so strict if it's not mentioned. If it's mentioned, it's good to put. The question is mentioned gas, so let's put burns in air. As we said in the previous class, hydrogen sulfide gas is a colorless gas which is the smell of rotten egg, foul smell. Okay, foul smell means not pleasant. Foul means not pleasant. Unpleasant smell of the rotten egg smell, similar to that. That's how we can identify hydrogen sulfide gas in the laboratory. Hydrogen sulfide gas burns in air means air is simply oxygen to give water and sulfur dioxide. So to give water a little bit below the arrow and sulfur dioxide, so a little bit below the plus, sulfur dioxide, SO2. So the skeletal equation is now correct. Skeletal equation means we have written in a symbolic form, making sure that every single formula is correct chemically. Now H is here 2 on the left side, no H, so on the right side also 2. So far balanced. Then S is 1 at the back. This 2 doesn't belong to S, right? This is the 2 is the subscript of H, means belongs to H. 2 is not a subscript of S. Subscript of S is no number, so 1. Right side also 1, so balance. O2, here is 1, 3. So that cannot be. So let us make here. Let me try. 2 2s are 4. Then here also 2. Okay, I think we need to be a little bit more careful here. 2. So wait just 1 minute. Let's try and see which one is easier to balance first. So if you were to put here 2, then 2O, 4O, and 2 2s are 4. So here H2, so 2 and 4. So let us see. Okay, so let us balance this here. S, let us put here 2S, here also 2S. 2 1s are 2S, 2S. Then 2 2s are 4H. Let's put here 2 2s are 4H. So let's start balancing with S and then go to H. Balance the all last is easier, I think, in this equation. So 2 2s are 4H, 2 2s are 4H. 2 1s are 2S, 2 1s are 2s. Then O is left, so 2 here. Then 2 1s are 2O plus 2 2s are 4. So 6O. Only one place here, so we put here 3 2s are 6. Then right side also 6O. 2O plus 2 2s are 4. 6O. Left side also 6. Now it's balanced. So in this equation, remember, it's easier to start balancing with S. Then balance H. And balance O last. S first. You balance. Then H you balance. Then O. Keep a little bit of try to remember that order. And it will become easy for you to balance this equation. So as you practice more, you will know which to remember first even, right? Let's read it. 2 molecules of hydrogen sulfide gas burns in 3 molecules of air or reacts with 3 molecules of air or same thing, whichever way you like to say it, to give 2 molecules of water and 2 molecules of sulfur dioxide gas. Sulfur dioxide, they didn't say gas, so you need not mention. 5. Then let us go to 6. So 6 is barium chloride react with aluminium sulfate to give aluminium chloride and barium precipitate of barium sulfate. This is a double displacement reaction, but they have given everything there. So barium chloride, write the formula: barium ion Ba2 plus, chloride ion Cl1 minus. So 1 will go here, 2 will go here. Barium chloride react with aluminium sulfate. So let's write the formula carefully. Aluminium sulfate, a little bit below the plus sign. And from the formula above it, aluminium ion Al3 plus, sulfate ion has this correct SO4 2. And 2 here, 3 means can't cancel. So 2 at the top of SO4 will go to the lower backside of Al. And 3 at the top of Al will go to the lower backside of SO4 only after a bracket. Because SO4 sulfate is a compound ion containing 5 atoms. You see here, 1 sulfur atom, 4 oxygen, so 4 plus 1, 5 atoms. Any ion containing more than 1 atom is called a compound ion. And when you're bringing a valency which is bigger than 1, like 3, 2, then if it's a compound ion, we need to put a bracket. If it's not a compound, if it's not, valency is not is 1 only, then we need not put bracket. Okay. Or so when these two react, see, you can do follow. Though the question paper there shows what is on the right side, even if they didn't show you, you can easily figure it out. See here, you can mark it in exam. You don't need to do this. You can do this by imagination. Barium will replace aluminium, means BaSO4. So just write BaSO4. And remember the starter, Ba2 plus, sulfate is 2, 2 cancel. So that's correct. And then aluminium will also go and displace barium. So aluminium, Al and Cl you write first, plus Al and Cl. And then recall the starter. Aluminium has a valency of 3 plus. Cl chloride has a valency of 1, so 3 and 1. So 1 will go here. 3 will come here. So this is nothing but. So we form this formula by remembering our starter, aluminium chloride. Very easy to figure out because this is a double displacement reaction and this is barium sulfate. So now we have written this equation and the symbolic formula formed correctly. So this is a skeletal equation. Most probably it's not balanced. So let's check and balance it. Ba, 1 on the left side. Here also 1. Cl, 2 on the left side, no Cl. 3. As we said earlier, when we have 3 Cl and 2 Cl like this, the only way to balance is put 3 in front of the 2. So 3 2s are 6 Cl. 6 Cl. Then put the 2 in front of the 3 here. 2 3s are 6 Cl. So Cl is balanced now. The moment you do that, Ba is disturbed. So 3Ba. Here also now therefore it must be 3Ba. Ba and Cl balance, go to Al. Al is 2, they're also now 2, automatically balanced. Then here S is inside the bracket, so 3 belongs to S also, so 3 1s are 3S, and here 3S balanced. Then next is plus is O, 4 3s are 12O, 3 4s are 12O. Right side, left side, every atom is balanced now. So let us read now. 3 molecules of barium chloride reacts with 1 molecule of, no number means in front means 1 molecule of aluminium sulfate to give us 3 molecules of barium sulfate. And this barium sulfate is a precipitate, okay? We can write PPT means solid. It will settle towards the bottom of the test tube, I think. Okay, and then 2 molecules of aluminium chloride. This is the balance equation. Now go to the 7th one. Let's go to the 7th. So 7th one is nitric acid. So we know nitric acid. The formula is from our worksheet 1++. We have memorized this formula because this is a very common acid. Reacts with calcium hydroxide. So we write here calcium hydroxide, putting a plus, and Ca calcium ion, Ca2 plus, hydroxide ion, OH 1 minus, 1 and 2 can cancel, so 2 will go to the lower backside of OH only after bracket, because hydroxide is a compound ion containing 2 atoms. More than 1 atom means compound, and 1 OH 1 minus cannot be shifted. So when these two react, the question is saying to give calcium nitrate and water. Calcium nitrate, so Ca2 plus calcium ion, nitrate ion, NO3 1 minus, 1 and 2. So 2 will go to the lower backside of NO3 only after bracket, right? Because NO3 nitrate is a compound ion containing 4 atoms, and water, and means plus. So this is the skeletal equation H2. So we have to balance now. H is here 1, here is 2. So we have to put here 2 in front to make it equal to the 2 on the right side. Next 2n, no n here. Here also 2 1s are 2n, balanced. Next O, 2 3s are 6O plus 2O here, 2 1s are 2, plus 2 3s are 6O plus 2O is 8O. So here also 3 2s are 6 plus here 1. So 6 plus 1 is 7. So most probably we'll have to balance this. So we'll put here 2. Oh, sorry, we have mistake with the hydrogen. Let's start again. H2 here on the right side. 2 1s are, let's start with H. Okay, let me do like this. Look here. 1H plus 2H, 3. Here is 2 only. So let's make this one first. 2 2s are 4H on the right side. Let's begin again. 4H. Then here 2, you put 2 1s are 2H plus 2H, 4H. Balance. Now let us go to the N. 2N. Here also 2N. Then 2 3s are 6 plus 2O, 8O on the left side. Then here 3 2s are 6 plus 2 1s are 2, 8O on the right side. Balanced. So now everything is balanced here. Ca1, Ca1. So here 2H plus 2H, 4H. 2 2s are 4H. 2 1s are 2N. Here also 2 1s are 2N. 2 3s are 6O plus 2O, 8O. 3 2s are 6O plus 2 1s are 2O, 8O, balanced. Finally, Ca1, Ca1. So this is balanced. So let us read the equation. The equation is 2 molecules of nitric acid reacts with 1 molecule of calcium hydroxide to give us 1 molecule of calcium nitrate and 2 molecules of water. Next question is 8. It's written there. Sodium hydroxide react with sulfuric acid. I write here sodium hydroxide reacts with sulfuric acid. All this name we write a little bit below the plus. This one also below the plus. This one also. And then we form the formula at the top. Na1 plus sodium ion hydroxide OH1 minus, here 1 and 1. Sulfuric acid formula from the worksheet 1++ is H2SO4. You can do that. React to give water and sodium sulfate. To give water and sodium, so write it a little bit below the plus, sulfate. So we'll form the formula. Water is so easy, H2O. Now the next one, remember your starter, sodium ion, Na plus, sulfate ion, SO4, 2 minus, so this 2 will go to the lower backside of Na. So Na2 SO4, Na2 SO4. Now we need to balance. So here Na is 1, right side is 2. So we have to put right 2 in front because balancing has to be done from the front and not in the back or middle. The 2O plus 4O, 6O. 4 plus 2 ones are 2 and 4O. Okay, let us go to H first. 2H plus 2H, 4H. So let's put here 2 2s are 4. H. That way, go back to O, 2O and 4O, 6O. 2O plus 4O, 6O. So Na balanced, O balanced, H balanced. Go to S, S1, here also S1. Okay, so now we can read the equation as 2 molecules of sodium hydroxide react with 1 molecule of sulfuric acid to give you 2 molecules of water and 1 molecule of sodium sulfate. Okay, next 9 and 10. So 9, silver nitrate. Write down silver nitrate. Formula Ag1 plus silver nitrate ion NO3 1 minus. So both the valency at the top are 1 and 1. So the formula remains like that. React with sodium chloride. Reacts with sodium chloride solution. Okay, they're saying solution anyway. Sodium chloride, the salt we eat every day in cooking our food. So here's Na1 plus, Cl1 minus, and then this is very simple. You see here, you can follow this technique. This will go here and this will go here. Okay, so Ag will go here, means it will become, just write AgCl and remember your starter. Ag is 1 plus, Cl is 1 minus, chloride, silver. So this is nothing but silver chloride. It will come out of your test tube as a white colored precipitate. Okay, when you mix these two, so white PPT. So pour this solution into sodium chloride NiMOC. Pour this sodium chloride into silver nitrate solution and immediately the white precipitate will appear. So it's a fast reaction. Okay, and then this Na will replace this, means NaNO3, right? And then correct it by remembering your starter. Na1 plus, nitrate, NO3 1 minus. So there is nothing to shift. This is the correct formula. So write your sodium nitrate. There is nothing to even balance, right? Because exactly is shifting Ag here, AgCl, Na go there, NaNO3. So it would be balanced. It will automatically be same both sides. Okay, next, finally 10. So let's write here 10. Sulfuric acid react with barium chloride. So sulfuric acid, which we know is H2SO4, react with barium chloride Ba2 plus, Cl1 minus. So 2 will go here. Barium chloride to give you, okay, here see, to give you, when a question paper is given, barium sulfate and hydrogen chloride. Barium sulfate. So it's very easy. You box this here. Barium sulfate. So it will become, always we have to write the plus first, right? Ba is plus, Ba2 plus, SO4. Then we know this is nothing correct. Barium sulfate. Right, Ba2 plus, SO4 2 minus, so 2 2 cancelled. Then combine these two, H2 and Cl, the only way outside the box. So this is the box. You don't need to draw the box in the test, okay? But during test, you box it with your imagination. Now you can actually box it while practicing it. Outside the box is H2 and 2Cl2, means the only correct compound that you can form is 2HCl. So this is nothing but hydrogen chloride. That way, you don't have to memorize. In the question paper also is given. Sulfuric acid react with barium chloride to give barium sulfate and hydrogen chloride gas. So it's already balanced here. Ba box, exact box here. H2, Cl2, 2 HCl, exact number, right? So it would be automatically balanced. So this is your Test-1D. Do it by watching. You have done along with me. Now you go through it, and if you're sure you're comfortable with it, then you can take the test. Okay.